Using moment area method, find the deflection at D and C and slope at A, B and C. This is the question of overhanging beam carrying point load as well as uniformly distributed load. If we observe, the flexural rigidity of this beam AC is different throughout the section. For part AB it is 2 EI and for part BC it is equal to EI. So we are going to use conjugate beam method because of this different flexural rigidity. First step is to draw the bending moment diagram. Now we know that bending moment at free end is equal to 0. So for this point A and at the point C we have to show the bending moment is equal to 0. Now we will draw the bending moment diagram so that we will extend all these points, that is point A, D, E, B, C in the downward direction. Now at point A we will show the value of bending moment is equal to 0, and at this point C also we will show the value is 0. Now how to calculate bending moment at point D? For that we will use this sign convention. We will take summation of forces multiplied by the perpendicular distance which are on the left hand side. So on the left hand side of this point B there is only one force, that is the support given at point A, and that is equal to 20 by 3 kilonewton. So how to take the bending moment? So if I move the compass which is D at the center and in the direction of this 20 by 3 kilonewton, then here is the direction. Now if we observe, this is the sign convention. So here is the clockwise direction and which is on the left hand side. So these two sign conventions are on the right hand side and these two sign conventions are on the left hand side. So for the left hand side and clockwise direction we have to use the positive sign. So we have to take positive, with positive sign, 20 by 3 multiplied by 3. So which is equal to 20. So this is the bending moment. So how to show here? So at point D we have to show here 20 and it is plus sign, and therefore we have to show in the upward direction. So we have to mark one point. Now next, bending moment at point E. So we have to take the summation of bending moments of the forces which are on the left hand side. If we take E as a center and move the compass in the direction of this 20 by 3, then again it is in the clockwise direction. So use positive sign. So 20 by 3 multiplied by distance. So distance of A to E, that is 3 plus 2, 5. Then next we have to take this uniformly distributed load. So what is this total value of this uniformly distributed load? So it is 20 multiplied by 2 because total span is 2 meter. So 20 multiplied by 2, that is 40 kilonewton. So we have to take this 20 multiplied by 2, 40, and the point of application of the load is at the center point. So from the distance E, from this point of application of load, it is equal to 1 meter. Now if I move the compass in the direction of this load, that is in the downward direction, then here we get the anti-clockwise direction. So for anti-clockwise direction and on the left hand side use negative sign. So how to use this? Minus 40 multiplied by 1. So here minus 20 into 2, that is 40 multiplied by 1. So when we calculate this, we will get minus 20 by 3. So this is the moment at E. So minus 20 by 3 we will plot in the downward direction. So here minus 20 by 3. Now we will move to the next point, point B. So again we have to take the summation of forces, that is summation of bending moment of the forces which are on the left hand side. So on the left hand side, this is in clockwise direction. If we move the compass about point B, so use positive sign. 20 by 3 multiplied by total distance from B, that is 6. Then again here 20 into 2 40, and the distance is this 1 plus this remaining distance is also 1, that is 2. So this total distance 2, and here this direction is in the anti-clockwise direction, so use the negative sign. So minus 40 multiplied by 2. So here we have to take, and which is equal to minus 40. So when we calculate this, we will get minus 40. So again we have to select this point minus 40. So I will select here this point minus 40. Now at point C it is 0. Now important thing, we have to connect all these points. Now if we observe the span AD, so here is the point D, then next point is point E, here is point B, and next point C. Now in span AD there is only one point load 20 by 3. So for this point load we have to connect with straight line. So this 20 and 0 we have to connect with straight line. Now for this DE, for this span DE, there is uniformly distributed load. So we have to show the parabolic shape. So at point D here is plus 20, and at point E there is minus 20 by 3. So we have to show the parabolic shape. So this is the parabolic shape. And then from E to B, so from E to B again there is point load. So again we will show here the straight line, and then B to C there is the point load. So again we will connect with. So this diagram, that is the bending moment diagram, is getting completed. But this is the conjugate beam method. So we have to add one extra step. Next step, that is the step 2, is to draw M by EI diagram. So this step 2, M by EI diagram. So this is M. Value of M is 0, then 20, minus 20 by 3, minus 40, and 0. Now how to calculate M by EI? So the values over the span AB is equal to 2 EI. So I have to divide it by 2. Now at point A it will remain 0. At point D, so it is 20 divided by 2 EI. So 20 divided by 2 EI, that is equal to 10 divided by EI. Then at point E, so at point E it is minus 20 by 3, but minus 20 by 3 divided by 2 EI, that is minus 10 by 3. So again I have to select here minus 10 by 3. And next is point B is minus 40. So for minus 40, point B is the part of this 2 EI as well as EI. So minus 40 divided by 2 EI, that is equal to minus 20 by EI. So I will select here minus 20 by EI. So here minus 10 by 3 EI. So we have to take here EI as a denominator. Then this is the part of EI also. So it is minus 40 by EI also. So we have to select. Here is minus 40 by EI. And then next one is 0. Now we have to connect all these points. So here is straight line. Then next one is parabolic shape for this D to E. So D to E, parabolic shape. Then next one is minus 10 to minus 20. Here is this shape. Then we have to connect with straight vertical line. And then here is 0. This is 0. So we will give here the name, that is A. This is the point D, then E, then B, and then C. So this is the M by EI diagram. in conjugate beam method, we will refer M by EI diagram and we will select the different areas. For the section AD, we will select the area A1. Then for the next section DE, we will select area A2. For section EB, we will select area A3, and for the section BC, we will select area A4. Now next step is to calculate the area as well as centroid for these selected sections. Now first we will take the area A1. So area A1 is in the span AD. Now if we observe, here is the triangle shape and here is the perpendicular. Now we can say this is base multiplied by height. So we know how to calculate the area, half multiplied by base multiplied by height. Now this height is 10 by EI, base is equal to 3 meter and multiplied by height, and which is equal to 15 by EI. So this is the area A1. Now how to calculate centroid? So centroid we have to measure always along this horizontal line. So here is, suppose we will select the centroid, location of centroid is this point. Then how to make the partition of this point? So if we observe, here is the perpendicular line. So from this perpendicular line we have to take the distance h by 3, where this total distance AD is equal to h. And from this centroid, this distance is h by 3. So what is the total distance h? That is equal to 3 meters. So we can say that 3 by 3, which is equal to 1 meter from D. So this point is important, 1 meter from D. So we can say that 2 meter from A. So which is also equal to 2 meter from A. So this is the selection of area as well as centroid for this section AD. Now we will move to the next section DE. Now for this section DE, how to calculate the area? So if we highlight this area, here is the section DE and here is the parabolic shape. So how to calculate this area? So there is no any formula to calculate the area for such a shape. Now here is the 10 by EI and at point E minus 10 by 3 EI. So these parameters are known. So we will use here the integration method, and we have formula A2 is equal to this integration from A to B mx by EI dx. Now mx we have to take the moment of all the forces along the section xx. Now this is the section DE. So in section DE we will take any section xx which is at a distance x from the end A. So here remember, we can take the distance from the free end. So either from end A or either from the end C. But for this section DE we will select this end A. So this is a distance x and it is at a distance, the section is xx in between section DE. Now we can say that the value of x is equal to 0 at point A. Then x is equal to 3 meter at point D. So I will write here, and x is equal to 5 because 3 plus 2 5. So x is equal to 5 at point E. So these are the values of x, but we have to measure the area in between x is equal to 3 to 5. So we can say that integration from 3 to 5 that we have to take. Integration from 3 to 5 we have to take. Now how to calculate this mx? Mx, that is the bending moment along this section xx. So again we will apply this bending moment rule. So sign convention, so the forces we have to take on the left hand side. So on left hand side, for this clockwise direction use positive sign, and for clockwise direction use negative sign. Now how to calculate mx? So first force is 20 by 3. Now if I move the compass at xx as a center and here, then clockwise direction, so we will use positive sign. So 20 by 3 multiplied by this distance from A, that is x. So I will use plus 20 by 3x. Now what about this uniformly distributed load? So we have to measure the distance of this uniformly distributed load from this D to XX. So what is this distance? So this total distance is x, and here this remaining distance we have to measure, that is equal to x minus 3. So I have to take x minus 3. Now this uniformly distributed load is given 20 kilonewton for 1 meter. So for a distance of x minus 3, what is this load? Here is the question mark. So load is equal to 20 multiplied by x minus 3 divided by 1. So load, we can say that load is equal to 20 x minus 3. And point of application of load is the center point, that is x minus 3 divided by 2. So x minus 3 divided by 2. So how to write the bending moment? 20 into x minus 3 square by 2. Now if I move the compass and direction is downward direction, so here is the anti-clockwise direction, and for anti-clockwise direction use negative sign. So moment is equal to minus 20 x minus 3 square by 2. So here we have to write this mx. Now this mx we get for this section xx. Now we will put the values. So a2 is equal to integration from 3 to 5, then this mx divided by ei. Now ei is, if we observe, for this section DE it is equal to 2 ei. So instead of ei we will write 2 ei, and here is dx. So this ei we will write 2 ei. Now we will simplify this. So when we simplify this, 1 upon 2 ei we will take outside the bracket because it is constant term. So we have to take integration with respect to this this for x. Now we will apply the rule. So integration of x raised to n is equal to x raised to n plus 1 divided by n plus 1. So here 20 by 3 we will write as it is. Now for this x raised to 1, so n is equal to 1. So we will write x square by 2. So this integration is completed. Now we will give the boundary conditions, that is 3 to 5. So here is 3 to 5 minus, now here 20 by 2 as it is. So here 20 by 2 as it is, x minus 3 square, that is n is equal to 2. So x minus 3 cube by 3. So we have to take here 20 by 2, that is 10, and here x minus 3 cube by 3. So this integration is completed and we will apply the boundary conditions. So this step is important. Now we will take the constant terms, 1 upon 2 ei, then here is if we simplify this 10 by 3, then instead of x we will put 5. So 5 square minus 3 square, that is 25 minus 9, bracket complete. In the second bracket, here constant term is 10 by 3 and here x minus 3. So first we have to take 5. So 5 minus 3, that is 2 cube, minus 3 minus 3, that is 0. Now we have to solve this. So when we solve this, then we will get the answer 40 by 3 ei. Now we will calculate the centroid for the area in between the section DE. So we will use the integration method. So we have formula to calculate centroid C. So centroid C is equal to integration from A to B, mx multiplied by x by ei into dx divided by area of that section. So here in this case area is A2. So we will write here area, or we will write here area A2. Now we know the mx that we have already calculated, that is the bending moment of at any section xx. For this we have selected in between this area DE. So we have mx value 20x by 3 minus 20x minus 3 square by 2 and bracket complete x multiplied by dx. Now instead of EI we have to take 2 EI, because for this section DE flexural rigidity is given as a 2 EI. And what about this A and B? So at point D value of A is equal to 3 and at point E it is equal to 5. So we have to take the boundary conditions from 3 to 5, because this area is in between D to E. So we have to take the value of X in between D to E and divided by A2. So A2 we have calculated. I will write 40 by 3 EI as it is. Now we will solve this numerator. So how to solve this numerator? This 1 by 2 EI is constant term. I will take outside the integration. Now inside this bracket we have to multiply with x. So we will take here integration of 3 to 5, 20 by 3 as it is. X multiplied by x is x square minus 20 by 2, that is 10 as it is, and inside the bracket we will apply the rule a minus b bracket square, that is a square minus 2ab plus b square, that is x square minus 3 multiplied by 2, that is minus 6x plus 9, and here is x. So outside the bracket x is there. Now when we multiply with this x, then this term will become x cube minus 6x square plus 9x. Now we have to take the integration for this. So 20 by 3, this is constant term, we will take outside. Now integration of x square, that is x cube by 3, and we will apply the boundary condition 3 to 5. Now here also minus 10 as it is. Now what is the integration of x cube? That is x raised to 4 by 4. Then minus 6 x square. So x square, that means x cube by 3 plus 9, x is x square by 2. Now this is the integration, and now we will apply the boundary condition 3 to 5. Now we will solve this. So 1 upon 2 AI, that is constant term as it is, then 20 divided by 3 multiplied by 3, 9, and here instead of x cube we will take 5 cube minus 3 cube, and that is 98 minus 10 as it is. Now x raised to 4, that is 5 raised to 4 minus 3 raised to 4 divided by 4, minus, now here 6 by 3 is 2, so I will write here 2, 5 cube minus 3 cube plus 9 by 2 as it is, 5 square minus 3 square, bracket complete. Now again we will solve this. So this first term will get 217 minus 10. Now inside the bracket we will solve each term. 136 minus 196 plus 72. So we will get 217 minus 120 divided by 2 EI. Now this numerator term I will take here, and denominator term 40 by 3 EI. So when we solve this we will get 3.63 meter. So this is the value, that is the value of x. So this x, that is, we can say that centroid is at a distance 3.63 meter from A. But from point D, how to calculate this? We have to subtract this 3, that is 0.63 meter from this end D. Now we will calculate area A3, which is trapezoidal shape and which is in between the section EB. So we will consider any section XX, and it is at a distance x from the free end. So we can select the point A or point C, but point C is nearby to the section XX. So we will select the distance x from the point C. So we can say that at point C value of x is equal to 0. So I will select here x is equal to 0. At point B value of x is equal to 2. Here x is equal to 2, and at point E, so this distance is 1 meter, so x is equal to 3. So we have to select the area in between x is equal to 2 to x is equal to 3. So how to calculate this area? So we have formula, that is area is equal to integration from A to B mx by EI into dx. Now first we have to take the moment of all the forces about this section XX. Now this time the forces are on the right hand side. So for right hand side we have to use these sign conventions. So when there is clockwise direction, use negative sign, and for anti-clockwise direction, use positive sign. So how to take this mx? So first we will find out this mx. So I will take the moment at this section xx. So here is at point B 160/3 force is there. So what is the distance from this section xx? So this total distance is x and this distance is 2 from the point C. So remaining distance is x minus 2. Now if I move the compass about the section xx in the direction of this 160/3, then here is the anti-clockwise direction. So use positive sign. So 160/3 multiplied by x minus 2. Now next is 20 kilonewton. Now this time clockwise direction on the right hand side, so use negative sign. So minus 20 multiplied by this distance is x, so minus 20x. So this is mx. Now what is the value of a and b? So here if we observe x is equal to 2 and x is equal to 3. So we have to take a as smaller value 2 to 3, that is integration from 2 to 3. This is the value of mx divided by ei. Now in between this section EB there is 2 ei. So we have to take 2 ei. Now we will solve this. So it is easy to solve. So 1/2 ei is constant term, we will take outside. 160/3 is also constant term. Now x minus 2. So x integration of x minus 2 bracket raised to 1. So x minus 2 square by 2, and now for this integration we will apply the boundary condition 2 to 3 minus 20 as it is. Now x, that is x square by 2, and we will apply this boundary condition 2 to 3. Now here x is equal to 5. When we put 3, then 3 minus 2, that is 3 minus 2 1 square, and this 2 we will take here, that is 160/6. So here is 1, and 2 minus 2 0. So here is 1 minus 20 into here 20 divided by 2 10, then 3 square minus 2 square, that is 9 minus 4, that is equal to 5. So when we solve this, then we will get minus 30 by 3 ei. So this is the area A3. Now it is easy to calculate the centroid. So we know the formula for centroid. So we have to take centroid C is equal to integration of A to B mx multiplied by x divided by ei into dx and whole divided by that area. So this time area is A3. So I will take here area A3. Now we will put the values. Now A to B, that is 2 to 3 mx. So here is mx that we have shown, mx, and multiplied by dx. So outside the bracket x dx divided by, instead of ei we have to take 2 ei. So here 2 ei divided by A3. Now we will first solve this numerator, and when we solve this numerator, then we will divide the value of A3, that is minus 35 by 3 ei. For this numerator, this is the calculation part. We will take 160/3 outside, then integration of, now we will multiply x with this bracket, that is x square minus 2x, and this bracket complete. Now this minus 20 as it is. Now x multiplied by x, that is x square. So we have to take integration from 2 to 3 for x square. Now we will solve this. So how to solve this? So 160/3 is the constant term for this whole bracket. So I will take 160/3 and inside the bracket x square. So what is the integration of x square? X cube by 3, and we will give the boundary conditions 2 to 3 minus 2 as it is. This x, that is x square by 2, and this boundary condition 2 to 3. Now this square bracket is completed. Now minus 20 for this x square, x cube by 3, and bracket complete, boundary conditions 2 to 3. Now instead of x we have to put 3 and 2. So 160/3 as it is, 1/3 is constant term, 3 cube minus 2 cube, that is 27 minus 8. Then minus this 2 and 2 is getting cancelled. So 3 square minus 2 square and square bracket completed. Now minus 20 by 3 as it is, 3 cube minus 2 cube. So here we have to solve this. So when we solve this, this is the calculation part, then we will get the answer 213 by 3 minus 380 by 3. So when we calculate this, we will get minus 167 by 3. Now we will put this value here. So it is minus 167 by 3 and this divided by 2EI as it is, and whole divided by area A3. So area A3 is minus 35 by 3EI. So when we simplify this, we will get 2.38 meter from C. Now why to C? Because this centroid we will get as a distance x. So x is from end C. So we can say that this centroid is at a distance 2.38 meter from end C. So it is 2.38 meter from this end C, and 2.38 minus 2, that is 0.38 meters from this end B, from the end B. Now we will calculate area A4. So it is of triangle shape, and if we observe its a dimension, then at this end point there is minus 40 by EI, and for the section BC the distance is 2 meters. So for triangle we know that half multiplied by base multiplied by height. So half multiplied by 2 multiplied by minus 40 by EI, which is equal to minus 40 by EI. Now how to calculate the centroid? So this centroid is along this section BC. Now here is the perpendicular. So this is the perpendicular. Now from this perpendicular point we have to take distance h by 3, and this remaining distance is 2h by 3. Now what is the value of h? This h is equal to this length BC. So h by 3, that is 2 by 3 from the end B, and 2h, that is 2 multiplied by 2, that is 4 by 3 meter from C. We have to show area as well as location of the centroid in the diagram. So here I have shown the area and location of this point G. Next step, that is step 4, is to find the slope and deflection. If we observe the diagram, at point A and B supports are given. So we can say that within these two fixed supports, this beam will bend in the downward direction. If I draw the tangent at point A to the slope, then the angle at this point A is known as theta A. And if I draw the tangent at this point B, then the angle made at this point B is known as theta B. Now I will draw two perpendicular lines. If I draw one perpendicular line from this fixed support B or from this point B, then here this vertical line that will intersect to the tangent. So this is tangent at the rate theta A. So if this intersect at this point, so this line is known as TBA. Now in the same way, if I draw one perpendicular line and that will intersect to this tangent at theta B. So here tangent at theta B. So this vertical line is known as TAB. Now we have to find out these two terms TBA as well as TAB to find out the slope. So what is this TBA? So how to calculate this TBA? So it is moment of M by EI diagram between A and B about B. Now if we observe between A and B, there are A1, A2, A3. These three areas are there. And we have to take the moment about point B, that is this area multiplied by centroidal distance. So for that, for this area A1 we have to take the centroidal distance, that is from this point up to this point, this total distance we have to measure. So first we will calculate this. So TBA is equal to area multiplied by centroidal TBA distance from the point B. So this is the formula. Now with the help of this diagram we will calculate. Now for area A1 I will take 15 by EI multiplied by centroidal distance. So centroidal distance, this distance D to B. So D to B distance is 3 meter and this centroidal distance is 1, that is 4, plus 40 by EI multiplied by centroidal distance. So here this centroid is there. Now from this centroid up to B distance we have to measure. So EB distance is 1 meter. So 1 plus 1.37, that is 2.37. Now next is minus 35 by 3 EI. And multiplied by centroidal distance. So this is the centroid in area A3 and this distance is 0.38. We will calculate the first term, it is 60 by EI, plus second term it is 40 by 3 EI multiplied by 2.37. So it is 94.8 by 3 EI minus this 35 multiplied by 0.38, that is 13.3 divided by 3 EI. Now if we observe the denominator, here this coefficient is 1 and here is 3. So we will multiply here both numerator and denominator with 3. So we can say that 180 plus 94.8 minus 13.3 divided by 3 EI. So we will get 261.5 divided by 3 EI. Now we will calculate theta A. So if we observe this triangle ABP, then in this triangle this theta A is equal to TBA divided by L, and L is the length AB and that is equal to 6 meter. So we will take here L is equal to 6 and this TBA term, and then we will get the answer with positive sign. So whenever this positive sign, then we have to show the clockwise direction and its unit is radians. In between theta A and theta B, theta A is known. So to calculate theta B, we will calculate theta AB because theta AB is equal to theta A minus theta B. So how to calculate this theta AB? So it is area of M by EI diagram between A and B. So in between A and B, there are A1, A2 and A3. These are 3 areas. So we have to take the summation of these 3 areas. So from the diagram we will take here 15 by EI plus 40 by 3 EI minus 35 by 3 EI. So which is equal to 50 by 3 EI. Now we will put the value and we will calculate theta B. So this theta B is equal to minus 6.42 by 3 EI. So because of negative sign we can say that this angle is in anti-clockwise direction. We will calculate deflection at point D. If we observe the location of point D, then it is at 3 meter from point A. So we will show here this is the distance 3 meter and this is the original position of the point D. Now if we observe, this is the bending of this beam AB. So this is the final position after it is bent. So we have to show here from D to D, this distance is known as delta D, that is the deflection at point D. So how to calculate this delta D? Now if I draw one perpendicular line from this point D on this tangent at theta A, then we will get TDA because in between AD tangent from this point, perpendicular line from this point D on this tangent at theta A. So here I will show this line and this is known as TDA. So we have to first find out this TDA, and when we find this TDA, then with the help of formula we will get this delta D. So this delta D is equal to this TDA minus multiplication of this angle theta A and the distance in between A and D. Now how to calculate TDA? So it is the moment of M by EI diagram between A and D about D. So we have to take moment of M by EI diagram. Now we will observe A and D points for this M by EI diagram. So there is only area A1, and how to take this moment? This area multiplied by centroidal distance from this point D. So centroidal distance is 1 meter. So we have to show this 15 by EI multiplied by 1. So this is the TDA. Now we will calculate delta D. So TDA minus, now distance between A and D is 3 meter multiplied by theta A. So theta A is calculated. So when we calculate, then we will get this deflection in meter. So it is minus 85 by 3 EI meter. Now because of negative sign, we can say that this deflection is in the downward direction, and we have to show this direction also. Now we will calculate slope as well as deflection at point C. Now if we observe, there is the fixed support at point B and this point C is the free end. So we can assume that there is the deflection of this part BC in this direction. Now we will draw one tangent line at point B. So if I draw here one tangent line, then the angle made at this point B is known as theta B. So we will say that this tangent at theta B. Now if I draw one perpendicular line from this point C on this tangent line, so here is the tangent I will extend and I will draw one perpendicular line. Now this perpendicular line from this point C is known as TCB. Now why this point B? Because this is the tangent at theta B. So TCB, and the distance in between this B and C is mentioned 2 meter. Now how to calculate the slope? So to calculate the slope at point C, because this theta B is known, that is one angle is known, so we can find out here theta BC. So theta BC we will find out the slope at this point C. So we know that theta BC is equal to theta B minus theta C, and then we can calculate theta C. So how to calculate this theta BC? So it is the area of M by EI diagram between B and C. So in between B and C we have to take the addition of the areas. So in between B and C there is only area A4 and it is minus 40 by EI. Now what is the value of theta B? So theta B is minus 6.42 by 3 EI. So theta C is equal to, so from this we can calculate theta C is equal to theta B minus theta BC. So theta B minus 6.42 by 3 EI, and this minus will become plus 40 by EI. So here also we will take the denominator 3 EI, that is 120 minus 6.42, that is 113.58 by 3 EI radians. So this is the positive sign. So we have to show the clockwise direction. So this is the slope at the point C. So this is the value of slope at the point C. Now how to calculate the deflection? Now this is the original position and here is the final position. So this C to C is known as delta C. So how to calculate the delta C? So first we will mention here the distance in between B and C. So this distance in between B and C is 2 meter. So we know the formula, that is this delta C is equal to this TCB minus multiplication of this theta B and this distance. So delta C is equal to TCB minus inside the bracket theta B multiplied by 2. Now this TCB, how to calculate TCB? So we have formula, that is the moment of M by EI diagram about the point C. So moment of M by EI diagram in between B and C about C. So in between B and C there is only one area A4, and how to take the moment? So we have to take the centroidal distance from point C. So here is the centroidal distance. So this is the location of centroid, and from point C 4 by 3. So we will take minus 4t by EI multiplied by 4 by 3. So this is TCB minus 2 into theta B. So theta B is this. So we have to take this inside the bracket. So when we calculate this, we will get the delta C minus 147 by 3 EI, unit is meter, and because of the negative sign, deflection is in the downward direction.